Nilesh Agarwal.
From Towards Scaling Inference. Towards Scaling Inference is a place where you can learn about ML deployments from zero to scale. We are very excited to have Jonathan from Voodoo with us today. He is working as a senior machine learning engineer at Voodoo and helping them build an ad network, an intermediary between advertisers and publishers. Previously, he has also worked at BNB Paribas Cardiff and worked on initiatives around speech recognition, OCR, etc. Thank you, Jonathan, for joining us today.
Yeah, thank you. I'm happy to be here to discuss with you about machine learning and deployment.
Yeah, awesome. So we would like to start the interview first by understanding that what kind of business problems are you solving through AI?
Yeah, so in my current post, I'm working on building an ad network project that aggregate and art inventories from our company, from supply source and match them with the demand source. So like you said, ad network is like a project that we try to match between advertisers who are looking to place their ad in another app or another games, and publisher has many apps or games running in the platform. So basically, we are building a bidding system. It means that a real-time bidding system to compete with other competitor, like Google or Facebook or Uploading or the other app competitor. So we can allow app developer to rapidly monetize the apps, and we use machine learning model, predictive algorithm to predict on many use case. For example, we predict on click-through rate, on install rate, on win rate, win probability. We predict also with multi-embedded. It means that we pick which ad we have to display to our user, so that it can show the best, and it can have us to have the best install probability at the end. So we have many model running at the same time and combining at the end with a particular formula, so that it can replicate our KPI business, so that we can optimize all together, and we generate the revenue based on that. So that is the project I'm currently working on.
Got it. Makes sense. And how do you currently deploy these models in production? So do you work with managed services like Hugging Face, AWS, or have you built your own ML infrastructure from scratch? Would also like to understand the pros and cons of the approach that you have taken.
Yeah, so currently we are deploying a model in production in AWS with the EKS services. We tried many different things also. Before we also tried SageMaker, AWS SageMaker, and we also tried the other platform. But at the end, we stick with our AWS and EKS service, and we built the custom infrastructure based on the EKS, so that we can continue to improve our custom infrastructure, and since over the other we have to dependence platform that's we are test before, but that is my current situation. But before I work at BNP Paribas, I also work in the internal projects that we use our own infrastructure. It means that our own local cluster. We build our own infrastructure to training a model, to deploy a model in internal use case. And what I witnessed is we had many problems with that. The most important, the most serious thing we encountered in the past is the first is the maintenance cost, because we have to have the team to maintenance our server, our own infrastructure, our everything. So for example, there is some problem with our cluster. Yeah, we have to deploy, we have to ask our team to deploy it, to go over there and to fix and to have many time to fix it. So it's called maintenance cost, it's time cost also. And so another important thing we have to consider is capability of skills. It means that when we have limited local cluster or our own infrastructure, we have limited capability of skills. So there are many problems. So after that, we decided to move on to cloud based, and which infrastructure is called Domino Data Lab. I don't know if you ever heard about it.
Yeah.
In BNP Paribas, we use Domino Data Lab. So we combine a cluster, cloud cluster in AWS via ONNX. ONNX is a company of telecommunications in French. So just they can help us to monitor the security of our data, something like that. Because AWS is something like working in the bank, we have to consider more and more problem of security. Yeah, so that's why we have to pass another cloud, and that cloud they use AWS also, but they add many layers to check, to verify, to ensure our security of data. But yeah, that is a cloud, and we also use the Domino Data Lab, and it helps us a lot in the training, in the deployment, in the safe storage data, and it's a share with other collaborators also. But the thing is, the drawback about it is that we have a dependence on the Domino Data Lab. It means that, for example, when we want to debug some problems that we detect from outside, that we think that it's from infrastructure, so we have to contact the team of the data lab, and we have to wait for 1 week or something like that, so that we cannot actively monitor from outside. So that is the main drawback, I think. And there's another drawback that we have to wait for a new update, a new release, so that we can have the newest features from their side. So you see what I mean? Because they have to scale, they have to apply for many companies, so they cannot how to say, they cannot reply immediately our demands, our problem from our side. So we have to wait for example, 2 months or 3 months, so they can release, and you can have a new release and can fix or can add another feature that we are demanding. So it take a lot of time as well. So that's why I'm comparing with the local cluster with cloud cluster. Local the infrastructure that we bind from us the third party with our own infrastructure based on AWS and EKS service. That's the solution we are using right now. So I think the solution we are using right now is more flexible. It asks, yeah, we have to use a lot more resource at the beginning, because we have to build a team to have the team to manage to build the base infrastructure. But after that, we have our own we have our own how to say, ownership of everything built on AWS, AKS, the release, the features we can add, and we can deploy our model in 1 week or 2 weeks. That is the main difference between our work at Voodoo and my work at BNP Paribas. I have to wait for one year to deploy a model, because it takes many times. It takes it had but at Voodoo we just 2 months maximum we deploy a model from scratch, everything. So I think it's very interesting to compare. But at Voodoo, the security of data is less critical than BNP Paribas, because so that's what you.
Yeah, no, definitely. It seems like you have a very broad exposure in terms of across all kind of deployment methods. So good to hear about that.
Got it. Awesome. And again, just like talking a little bit more about the previous part of deployment, right? So let's say before you prepare the model, right? So do you deploy them, let's say, in native format, or do you like right now there are a lot of conversion things to ONNX, TensorRT, to like optimize performance, right? Do you also guys run some conversion pipelines?
Yeah, it's yeah, exactly. It's because when I work it's a problem of OCR or speech recognitions. It's kind of big model, so we have to convert it. Firstly, we have to convert it into ONNX formats because such formats can improve our inference time and less dependence on the platform in the hardware platform. So ONNX format is our preferred options to deploy our service. We also test to deploy on Tensor serving or something like that. But because we convert everything, every project into PyTorch, so it's more convenient for us to convert into ONNX formats, and we seem very happy about it because it helped a lot in inference time in dependence platform, and it compatible with many kind of model.
Got it. Got it.
Yeah, that's my work at the BNP. Right now, I'm working. It's not in deep learning model. It's the deep learning model, but it's not in unstructured data. I'm working in the structured data. It means that many source data coming from a user, from inventory, from our game to everything. We put together in tabular data. So in the tabular data, we deploy them in the native format. It's something like a scikit-learn pico or something like that. Yeah.
Got it. So you're saying whenever it was a deep learning model in your history of deployment, then you preferred converting it to ONNX, because it gave you flexibility of like hardware compatibility because it runs on a wider array of hardware. And then second, it also gave you like a lot of speed in inference, right? So those are like previous like things that like help you. That's why you went with ONNX, right?
Yeah, and it's the ways of converting. It means that the process of converting a model into ONNX is it's kind of instantly. It means that we have a process to convert it directly, and as well, and also, for example, in the Hugging phase, something like that, the platform they can convert directly in ONNX also. So it's very convenient for us to use the ONNX format and to process it because many platform, many libraries support that also.
Got it. So you're saying that there's a wide variety of libraries that allow you to convert, right?
Yeah.
Got it. No, this is super helpful, and especially for the ML community who is probably like using different formats. So there's PyTorch, there's TensorFlow. These are very two like used one, but then again, each of them have very different deployment framework, right? So so I totally understand that converting it to ONNX can make it like easily scalable and deployable, right? Got it.
Exactly.
Got it. So now the next question, right? Now, so also wanted to understand, like in your current company, that are most of these inference workload real-time, batch, or streaming, right? What are the different types of use cases there are, and like how have you handled them? What are the challenges with each one of them? Would love to understand.
Yeah, so I already working in the real-time prediction and streaming predictions in our current use case. I already working on the batch prediction also in my previous work experience, and I can say that first in the real-time predictions, our solution is like I said before, we deploy them in native format. It means that we can save in this scikit-learn pico, or we can say in the PyTorch pico, because it's kind of the model. We don't need to convert directly into ONNX. And we load a model into memory cache of our deployment. And after that, we check every 10 minutes. If with the system see any change, any modifications in our base model, it means that because we have many models, we have many checkpoints, and we compare the versions, the ask version with our model, is our current model. If there is some change, we load the new model. If there is no change, we don't load the new model. We don't load anything. So keep our model inference in memory cache so that we can do the real-time predictions effortlessly. So, and that is about the inference terms. In the we have to use some kind of real-time tools for our data. For example, for DynamoDB, we have Kinesis, we have in the AWS, we have to use some monitoring and logging tools to track the real-time operation also, such as Grafana or Prometheus. Prometheus and Grafana combined, and so that we can survey, monitor operations, our systems in real time.
Correct.
Yeah. So that is the real time predictions. In batch predictions, the problem is that the model we have to process a large number of requests in the batch, right? Because we can receive, for example, we can receive 1,000 documents or 1,000 codes at the same time, and we have to do the batch predictions for 1,000 codes. So the challenge we face is BMP Paribas that we have to optimize at the same time the batch processing time, and for the total batch, it means that we have to fit the total batch in our memory, and we have to improve the total batch processing time also, because we cannot do the one by one in our batch. We have to do the in parallel, right? Parallel processing technique. So we have to we use some kind of technique to deploy everything in parallel. So we can use Kubernetes. In the Domino Data Labs, they have the Kubernetes can help us to deploy a multiple processor, multiple nodes of Kubernetes, and that helps us to reduce batch processing time. We also combine with the model. It means that in the model we can add the batch prediction, right? So we can increase the batch prediction. If it means that if we want to increase the batch size of our operations, we have to balance between the memories of GPU, memory of CPU, the inference time, and something like that. So yeah, so we use many techniques to do the parallel processing technique for batch prediction.
Correct. And in terms of like real time versus batch, do you see that the infrastructure cost for real time is high because you have to always keep these models on, and like is that a big challenge, or are these models small enough that like the cost part of real time inference is not like a big impact?
You mean that do we use any platform for real time prediction, right?
No, so I wanted to understand for real-time prediction, like as you told that you already keep the model in memory, right?
Yeah.
So does that mean like, let's say, if let's say there's no usage happening, right? Then does that machine still stay on and like cost you a lot? Like, is your inference like real-time load very like spiky, or is it very constant? Like, is that also issue where you have to like scale up, scale down services constantly?
Yeah, that's exactly that is a problem we face many times, because firstly in our use case real-time prediction, in our use case real-time bidding is very critical. We have to output a prediction in less than 200 milliseconds, because that is a time limited, or 300 milliseconds is a time limited for the bidding process to receive a bid. Platform to receive a bit. If we pass above 300 milliseconds, our bit is not accepted by the platform, and so we cannot bid on this place. So it's the most important critical. So more important factor in our systems, and so we see a lot of big in our operations, because firstly because the model size can increase. It can go deeper. It can the type model can go bigger, and we have to use some kind of compression model to compress our model first in that case. And so we have to deal with memory, like you said, and the machines, because we have to beat, for example, I think we beat 2 million bits per day, more or less, more than that. I think 2 billion. Yeah, 2 billion. I think 2 billion bits per day. So our machines, our cluster, we have to run on times. The model will load on times, and we have to deploy every day the model, running, training, deploying every day. So our system can detect the new model every day. We see a peak also, but we can manage this in the time frame that accepted by platform.
Got it. And let's say, since you have to maintain like such a crucial, let's say 300 millisecond latency, right? So do you usually over provision hardware where, let's say, if hardware is also not getting used, it's fine, but you definitely like try to like over provision rather than under provision?
Yeah, exactly. Sometimes we have to increase, to change our worker machines to firstly to can hold in the memories our model, because the model it can go bigger, and it's quite because the cost of the machine it can go quite high, and it costs a lot in the infrastructure, and so that's why we have to balance between the deeper model and the accuracy. It means that we have to balance between that. We choose the most reasonable one, and we will not go with the one that's the most accurate, the most accuracies in our system, but we have to pick the most reasonable one, the one that can produce accepted present with accepted memory and accepted inference time. So we have to consider a lot and change a lot of times the machine to benchmark, so to pick the one that confident with. Yeah.
Got it.
That
So you're
is a
saying
for
for latency and accuracy, you say that you already have like a system defined latency. So you have to consider the best model which does it within this accuracy frame, right?
Yeah. So between the latency and model accuracy, it depends on the use case. For example, in real-time bidding, in real-time variations, the latency is kind of the most important. Is the limit. For example, we have 300 millisecond limit. So we have to force from outside that for every model, all the model combined, all the system combined, we cannot go over 150, so that we can have a margin of inference time. For some reason, it can go over 30%, so we have to force from outside that we cannot go over 150 milliseconds. So latency is very important, because as you can see, the latency and model accuracy is like a trade-off. Where we can go deeper from our model, from our architecture, can get higher accuracy, but the latency is kind of trade-off for that. It's a kind of a drawback. So in our real-time prediction, we favor the latency more than the more accuracy. So our solution is that we draw a curve between the latency and accuracy. So the curve will be decreasing, right? But we picked the one that maximize it's not maximize, it's the one that's reasonable accuracy and in the limit of latency. So we every time we trace a curve like that, and we pick the most reasonable ones. It's not the best one, but the most reasonable one. It's very critical. It's a real-time prediction. But in batch prediction, it's not another story, because latency is less critical. It's not. It's important, but it's less critical. It means that we can run our batch prediction overnight, for example, and we can have the predictions tomorrow for our business case. So we have to so we have more machine for the model accuracy. We can go deeper. We can do some kind of complex technique, so that the batch predictions can
rely more on accuracy.
Yeah.
No, this is super helpful, and I think for all the people who are also building models, they can also like understand that how do they properly pick for real time versus batch. So the like great insight. So just last question from my side, and then I'll probably hand it over to Aishwarya. So just wanted to understand when you like train these models, let's say for like PyTorch, TensorFlow, or like even Scikit, right? Have you built your own serving runtime, or are you using like Torch script, TF serving, or something like that? Just wanted to understand your experience on that.
Yeah, my experience with that is before we have used TensorFlow serving. I think back to 2018. Yeah, we use a lot of our model in TensorFlow, so it's very convenient for us to TensorFlow serving. And at that time, I think TensorFlow is the best. TensorFlow 1, I think, is TensorFlow version 1.0. And so we come up with the TensorFlow serving, and because it can handle multiple model, multiple versions simultaneously, and support various deployment configuration, something like that. I think is one of the best at that time. But we changed our strategy, we changed our infrastructure into PyTorch a lot, because as you can see in training right now, many model, many platforms support only PyTorch. PyTorch allow flexible research and something like that. So, and our work focus a lot on the research development also. So we convert totally a model into PyTorch. So into PyTorch, and PyTorch to convert into TensorFlow serving, we can, but it can create many problems for the accuracy, because between the two, create many problems between the version, because the two is not matched together. So we change our strategy, we change completely to ONNX runtime. So we convert our model in ONNX format. It's like we already discussed. And ONNX, we have on ONNX runtime also. So in Pipariba, we changed to ONNX runtime, because it can have a high performance inference engine, can compatible with many different hardware, like we already discussed, and compatible with ONNX formats we already discussed. So ONNX runtime we use in the deployment, and we put it into the Kubernetes platform, and it runs very well. I think.
Got it.
Yeah, I think that time is one of the best. I think best option and best decision we made so far at BPA.
Yeah, no, definitely makes sense. So my question here would be that how do you manage and scale your infrastructure for inference as your usage grows?
Yeah. So that is one good question, because we at the Voodoo we have a lot of problem with scale, because we have to manage with more than three, like I said at the beginning, 350 million active user, and it can grow so fast in our company, and our use case grows exponentially over month. And the first option we choose at the beginnings, we stick with that, is auto-scaling at in AWS. It's very nice for us. It's very nice to handle. I think it's worked very well. And yes, we encounter some problem. We discussed with Amazon, for example. We use at one time we used serverless on. I think serverless Redshift serverless for our running for the training, and we encounter a lot, because it's kind of new service, and it can have auto scaling also in the serverless Redshift serverless. But that is a minor problem. I think overall auto scaling is AWS is scale very well, and it adapts very well in our use case, and so far it's good, I think. And besides that, we have to use another tool and monitoring. It's very important. I think it's one of the most important things we have to do at the beginning. Tool for monitoring, looking when our user base grow exponentially, and our option for that is Prometheus and Grafana. So far, I think it's very good. We can track our user, track our inference time. We can track the peak of patient. We can track and everything. And in open source also, I think so. It's not a problem for us to develop on that. And yeah, and at the Voodoo and at BNP also we see users grows because we have to deal with many countries in our use case. Firstly, we use only one country, but after that we scale on many countries. And at first we use only CPU for our hardware, but after that we decide to do multi-processing for GPU. So we have to do some scale on GPU. So to be fast on one side, and that is the option I think we choose to scale of speech recognition, so we can accelerate use a specialized hardware, so that can scale our infrastructure for inference.
Makes sense. No, definitely a very interesting insight on like the scaling aspect. Just one last question, from our side, that can you discuss any best practices or tips for other ML engineers who are looking to deploy models in production based on your experience?
Yeah, that is a very good question. I think there can be a lot of practice. We can only encounter in industry in working is a problem. But I think my first practice tips is we have to know very best at our best knowledge just from business side. It means that for one use case, if we have to grow, for example, at the beginning, our project of our network, we only use on a specific domain, specific country, for example, US or Canada. But we have to see far from that. We have to think that we have to deploy for every country, all worldwide. We cannot stick only with one country. So we have to prepare every option, every scenario for that scale. And it's okay. So business, we have to go along with it. For example, each country can have different configurations, different business KPI, different treatment. So we have to first think about that at the beginning, before anything else, before model, before infrastructure, before we have to think that we have to grow scale at the beginning. So we have to prepare every option, every step for that. That is my first practice. The second one, I think, is very important, but many engineers forgot or ignore about that, is monitoring. I think it's one of the most important, because when we deploy, when we build the monitoring at the beginning, we can detect many problems at the end. Along our project, along our skills, and monitoring is better to go with at the beginning, at the first second that we build a model. So we have to stick with monitoring. We have to see that if we have many problems or something like that. As monitoring, we have to detect. We have to implement also some kind of anomaly detections, or some kind of automatic issue. For example, we have to put some threshold to see that if the spike go over there, so we can will alert us instantly, so we can detect that instantly. Because in the production there are many things missing, many things that run well, but we cannot detect them with our own eyes. We have to put some automatic alert, so we can alert every time that we encounter a problem. That is the second thing I think is one practice. The third thing relating the machine learning model, I think in the industry, in the research, we see a lot of many benchmarks, many good architecture, many complex architectures that beat another benchmark over benchmark, right? And but industry is I think it's very different story, because we have to not only take into account the model itself, we have to put everything into account, between latency, between the memory cost, between the scale, between the budget of our company, between the budget of our resource team, between so everything we have to put into account. We cannot pick the best one in the industry. We have to pick, we have to improve our product, but more because over time we can improve it. The most important thing is that we should not think always think about the best model. We should think about the reasonable model in the industry, because when we think only the best model, we cannot deploy it. It's sure. I think it's very sure that cannot deploy it. So reasonable model, I think many engineers or many researchers cannot accept that or cannot think about that. But I think it's one of the best lesson I learned working in the industry over 6 years. And the last one, I think nowadays, if we have a platform like you are building, or another platform like we are already seen at Lumino.lab at BNP Paribas, I think it helps a lot for machine learning engineers to focus more on the model, for the data, for the monitoring, something like that, and let's care about the deployment complexity. Because it helps us a lot, because you know, in machine learning engineer, we do a lot. We do machine learning model, architecture, mathematics. We do a lot with the engineering part. It means that deployment, we have to do a coding part also. It means that we have to optimize our code. A lot of things we have to take into account, the business use case also, business KPI, and things like that. So many things we have to learn, many things we have to improve. So we have some tools to help us to improve, or to work automatically on some domains, is very helpful. I think nowadays more and more industry go over that direction, right? Because the kind of automatic.
No, I think definitely, I think all the 4 points that you mentioned in terms of tips, right? I think these are some great actionable for, you know, any engineer, data scientist who is looking to kind of deploy the ML models. Again, thank you so much, Jonathan. I think I will definitely like to acknowledge this is one of my best episodes so far. I think you went so much in depth. And also, you know, you came up with a lot of experience across the domains, right? From building internal ML infrastructure to, you know, working with managed services. So I think personally, I really enjoyed this session. I got to learn a few very interesting things here. So thank you so much.
I'm happy to discuss about it, and I'm think also I'm lucky to work on many use case, many different data. That's what I'm like the most. From natural language processing, from computer vision, from real-time bidding, and something like that. So I think, the experience, I learned a lot, and I enjoy very part of my work, every part.
Awesome.